back from coffee, back with coffee. It's an honor for me, to be the chair. By the way, my first time being a chair at a conference, but I hope I'll do quite well.
It's an honor for us as well.
Yeah, thank you. We have 3 interesting talks in the category of language design. And the first talk is on refactoring dynamic languages. It's taught by Rafael Reia, and he's from the Technical University of Lisbon. And I hope you'll all enjoy this wonderful talk. The stage is yours.
Thank you. Can you hear me? Okay. Good morning. My name is Rafael Reia, and I'm going to talk about refactoring dynamic language, which is the topic of my master thesis I'm developing under the guidance of Professor Antonio Leita. In order to become proficient in programming, it is necessary to learn about the syntax and semantics, about the programming language, but also about the pragmatics. Pragmatics are the style rules adopted and the logical rules that allow the user to create simple and understandable programs. Since beginner programmers often do not have enough knowledge about these rules, it is not surprising that their code reveals what more experienced programmers call poor style. Well, they start learning, and the learning process might take a considerable amount of time, and as a result, large amounts of poorly written code like this are written. And after learning, they decide, when they have to work it again, they decide to restruct it, so the code now has the style rules and logical rules that is accepted. However, in most cases, these modifications are done without the knowledge of the initial restrictions and requirements, and therefore they might introduce bugs. The previous example, it was only removing the if, but this example, since the false and the true are changed, it would introduce a bug. The correct restructuring would have to introduce a not, and it could be further improved by removing the not. It is thus important to help the programmer in this task, so the refactoring that you want or the restructuring that you anticipate, it will be effectively applicable and will not change the meaning of the program. This has been the main goal of code refactoring. Code refactoring is the process of changing a software system in such a way that it improves the internal structure of the system while keeping the external behavior. Nowadays, any sophisticated IDE includes an assortment of refactoring tools, like for moving methods along a class hierarchy, transforming anonymous classes into nested classes, etc. However, it is important to note that these IDEs were designed like Eclipse for more advanced programmers, and they are really complex. They have like a lot of windows and a lot of menus. And the refactoring tools are also complex with a lot of options and require a certain level of code sophistication that is not present in the code written by beginners, thus making it inaccessible to them. So we present a tool that addresses the previous problems, and it's usable from a pedagogical IDE designed for beginners. It's capable of analyzing the program's code and informing of the typical mistakes made by them, and can apply refactoring rules that restructure the program without changing its semantics, with some exceptions. So, we are going to talk about some techniques used to do the refactoring operations without changing its semantics. The first one is the AST, Abstract Syntax Tree, and it's basically used as a main representation of the program. The tree on the right represents the program on the left. The next one is the program dependence graph, and the program dependence graph, or PDG, explicitly represents the key relationship of dependence between operations in the program. For example, that one operation cannot be after another, or otherwise the semantics of the program will change. Again, the graph on the right represents the program on the left. The last one of the techniques that we are going to present is the deaf user relations. The deaf user relation basically expresses where a function, a variable or expression is defined and its uses. Here you see the Ackermann and the three uses of Ackermann in this program. Since it's a common practice to start teaching beginner programmers using dynamically typed language such as Scheme, Python, or Ruby, our focus was on those dynamically typed language and more in particular those that promote a functional programming paradigm. In its now classical work, Chris will present the refactoring tool for Scheme that uses two sources of information, an AST and a program dependency graph. It uses the abstract syntax tree, or AST, to represent the main structure of the program, and it uses the program dependency graph as a way to prove that the transformation preserves the meaning and as a quick way to retrieve needed dependency information. The next two refactoring tools are Rope and Bicycle Repairman. Both were written in Python for Python, and both use an AST and the def-use relations as a way to do the refactoring operations. Rope assumes that the Python program has only function calls and some definitions, and therefore by simplifying the complexity of the program, it simplifies the complexity of the refactoring tool. The last refactoring tool that we are presenting is the PyCharm Edu, or PyCharm Educational Edition. It is an IDE for Python created by JetBrains, the creator of IntelliJ, and it was special designed for educational purpose, and is a simpler version of their PyCharm community IDE. The PyCharm Edu, it even integrates a Python tutorial and supports teachers that want to create tutorials or tasks for their students. However, the refactoring tool did not receive the same care, and it is exactly the same as the PyCharm community, the older brother, that has refactoring tool operations for advanced programmers. We also developed a refactoring tool, and we implemented it in Dr. Racket, which is a pedagogical IDE used in schools around the world to teach basic programming concepts and techniques. Although that our refactoring tool can work with several programming languages, its main focus at this moment is Racket. It's a Racket programming language. So this is the architecture of our tool, and can be seen as having three parts: the producers of information, the manipulators, and the printer. So we use two sources of information, the abstract syntax tree and the def-use relation. The abstract syntax tree is produced in its original form in the reader and in the expander form in the expander. The expander form is as the macros expanded and the lexical scopes. The def-use relations are computed in the compiler in the background, and both the ASTs and the def-use relations are only computed if the program is syntactically correct. Here in the transformer, it's where basically the refactoring operations are done. It uses the information from the both ASTs and uses the code walker to walk those ASTs, and uses the information on the def-use relation to provide refactoring operations that are correct. And the printer is where it has a job to print correctly the output back to the editor, and it currently uses a pretty printer provided by Racket. Now you're going to see some examples of the refactoring tool, semantic problems faced, and then some features. So this is the initial if that you saw previously in the presentation, and this can be improved to a not. Then this not can also be further improved to less than equal. Now this is a more complex example. It is a function that prints the first n Fibonacci sequence numbers, and basically the let computes those numbers, and the for prints the list. So we are going to extract the for because it basically prints lists. So now a little bit more into how the refactoring tool works. To extract the function, we have to compute the arguments. And to do that, we have to check whether it is defined inside the to be extracted function or not. We start by the fib, and since fib is inside the function to be extracted, we are not passing as an argument. However, in the other end, fibs is not defined inside the extracted function, and it's defined outside. Therefore, it will be an argument of the extracted function. Now, where should we locate the extracted function? Should it be outside or otherwise? Well, since it's up to the user, we solve this by letting the user decide, and we put the extracted function in the clipboard. In this example, we decide to put outside, and this is the call to the function. Now, some semantic problems. Well, we have this if, and it could be clearly improved. However, we have two options. The when, that is what most users will do, and the and. The and is the semantically correct option, since when the condition of the when is false, the when returns void, and the if returns false when it's false. So we decide to keep them both, since the and is the correct one and the when is the most used one. So we think that a user might want to choose which operation from these ones to do. Now, some features. Since it's for beginners, and they are learning which refactoring operations exist or are and what they do, it is important to help them. So we have refactoring suggestions that basically suggest possible refactoring operations to the user. It basically highlights which refactoring operations can be done in the code, and so the user will decide or not to do it. However, since the user it's a beginner and does not know which will be the result of the refactoring operation, we add the previewing, which previews the outcome of a refactoring operation, and then the user decides whether or not to apply the refactoring operation. In order to evaluate it, we want to ask two simple questions. Is refactoring useful for beginners? And if so, which are the important refactoring operations? To do that, we took a bunch of final projects in the introductory course back in my university, and we gathered some examples, and then we refactored a few of those programs. This is one of the examples, and it's very typical one, that has this kind of if that could be easily restricted to this by removing the redundant if. This is a bit more complex one that has two redundant ends, and it could be restricted to this. It's important to note that we also remove the EQ. However, this is another one that changed the semantics, since it has a slightly more flexible condition, and it's only compares this and not compares if it's true. This is a nested if. I had to put it like this to show the full program, but this is a more easy to see. And it has like the typical structure of the nested if, and could be improved to a cond. This is like the visual impact of the restriction, and as you can see, it's more compact, easier to understand, and in the end, maintainable. These are the results. We basically had a reduction of 10% of the lines of code in the program, except in this case that we have around 20%, since this program has a lot of repeated code that could be easily extracted to functions. So these are the number of the refactoring operations applied. And there are a lot, and they mostly changing ifs and conditions. Removing begins happens when you use the begin when it's not needed to, like in lets, cons, or whens. And the last two are the more structural operations that have a bigger impact in the structure of the program. So Python. 2 years ago, a colleague of mine, Pedro Ramos, presented in this conference an implementation of Python to Dr. Racket. So, and since it's replacing Scheme and Python in introductory courses around the world to teach beginners, we decided to do refactoring operations in Python. we started with the simple ones, like removing unnecessary ifs. And then we went to reusing the features that we already provide for the Rackets tool. The previewing of the refactoring operation and the highlighting of the possible refactoring operations, the refactoring suggestions. In the future work, we want to improve the automatic suggestion by adding different colors for the different types of refactoring operations detected. And we want to add the refactoring detection. The refactoring detection basically detects when the user is manually doing a refactoring operation, and then the tool prompts the user if he wants us to finish it for him. Thank you.
Okay, thank you for your interesting talk. We are really good in time, so we have a lot of time for questions. Yeah.
So the examples that you showed with that massive if tree.
The examples, if...
Did students actually write those?
Yes. And I will give you a better example. When I did this course, I looked to my code and I did something similar to this or even worse.
Did you do that as an undergrad or?
And I was doing my computer science course the first.
Okay.
Yeah.
And so I'm guessing that my guess was that students did write that. How many students wrote that?
This kind of
Not
ifs,
exactly that, but in a lot of
nested
nested ifs.
ifs. Well, I didn't see that much examples, but like 3 or 4. This was the easiest and the cleanest nested if that I could find. Because otherwise they have like a lot of conditions and something that could be improved, and the nested if wouldn't look that bad. But yeah.
And so the follow-up to that is, did the students, assuming that this refactoring happened, did the students learn from that refactoring, or did they continue to write it?
I did not test it with students. I only took the examples from students to check whether or not the should be. Yeah.
So you haven't seen the students? You haven't
Yes.
seen it in actual use by students just yet?
Yes.
And I can also comment on that because we are using Dr. Racket in teaching undergraduate students. And my experience is that the first thing students learn right now when they sit in front of a computer is copy and paste. So I assume that 80% of the undergrads are producing such code once in their academic career. Okay, other questions?
The man page is Stack Overflow.
Okay.
How are you handling previewing of large refactorings like that?
I cut it because I have a limit or the. Yeah, it's not the cleanest way. It's. Yes, but it give you the. If it will be a large refactoring, it will be like an if to cont, then you check whether it is or not. And so they get an idea and. Yeah.
In the Dr. Racket editor, is that flexible enough that you can provide some other kind of previews?
I didn't explore that. I didn't explore a lot of things like deeply since it's a master thesis and I have to deliver it. So yeah, but I want to explore that a little bit further.
No, it's you. Yeah.
I have a question about how you compute the def use information. Do you compute it directly from source code, or do you reduce it to some intermediate language first?
I basically used what Dr. Racket uses to compute the def use relations. As you see, like in the beginning, like those arrows. Mm-hmm. Oh yeah, this is an arrow. This is Dr. Racket computes it, and basically, since I did not have access, I had to do a little add and I had to copy it. Yeah.
Yeah.
Does it preserve comments or other?
At this moment, no, but it will be easier to do. I just had to add another syntax object to the abstract syntax tree, and then the comments will be preserved.
How do you want to approach the automatic detection of the user is trying to refactor code?
I didn't think about that much. I only thought that it would be really cool. And I read a lot of papers that a lot of users, even advanced programmers, they start doing a refactoring without knowing that they are doing a refactoring. They are just changing stuff. And by having the tool to prompt it to the user, it will be really efficable.
So you're thinking about
It will not. I don't know because I didn't explore that, but for beginners it will be more interesting since the refactoring would be simpler, and will not annoy the beginners that much because there are simpler stuff, easier to understand what they're doing, etc. For advanced programmers, I have no idea how it would be done, and I hope it will not be clippy.
Yeah. But to add to that, for example, since you referred to IntelliJ idea, at least the version for Java has something like that. I mean, it recognizes some patterns and it asks you if you want to refactor them or not, and you can disable them on a case-by-case basis.
Okay, I didn't know. I didn't know that.
Working a while to do that, so probably it's useful.
Okay.
Could you talk a little bit more about how you resolve ambiguity? So you have that example of it could be a when, it could be an and.
Yeah.
More cases like that.
That's I like here. To do that, this is like the refactoring option. Then I could have the end here and the when in the lower. The user decides whether or not he wants to do it. So I would show him both options.
Why do you use PyStreet defaults function and afterwards function? And can you refactor code with user-defined macros?
With the last part, I didn't understand the last part.
Can you refactor code with user-defined macros?
Okay, the macros, I didn't test it since it's for beginners and usually they won't do macros. The other part is the expanded code in Racket has really few information since like the cond is a macro for Racket, it's expanded to ifs, the less and equal is an if, etc. And the end is an if. I don't know the less, but the end is an if, nor is an if, etc. So I use the original one to do the refactorings, and I use the other one to check if the bindings are correct, and so on, so on.
Other questions? No. Okay. So thank again.
Okay. Thank you.